Welcome friends. Today we are going to learn about rewinding of 3-phase induction motor. Let us see the motor details. This is the nameplate of the motor. We will see one by one. This is Crompton grease make motor and its capacity is 1.5 kilowatt or 2 HP. 3-phase motor, frequency 50 plus minus 5%, voltage input should be 415 plus minus 10% volt, and current, if it is star connected, then it will take 3.4 ampere. RPM is 1405 RPM. Insulation is class F. So it can withstand temperature up to 180 degrees centigrade maximum and average 115 degrees centigrade. Due to its S1, that means it can run continuously. Ambient temperature it will withstand is 45 degrees centigrade, and ingress protection is 5.5, that is first 5 for dust particle entry is restricted, and second 5 is protection against nozzle water. And bearing used is 6205 in both ends, that is it is a single row radial ball bearing with ID 25 mm. Presently the motor is in the machine. First we have to open the terminal box and disconnect the 3-phase power supply. Then we have to check the resistances from the terminal boxes. There are 3 phases here, and as it is inside star connected, outside will be only 3 terminals. In other cases, in 3-phase motor also you can find 6 terminals, A1, A2, B1, B2, C1, C2, but this case only 3 terminals A, B, C. So we have to check the resistance between 2 terminals. It is showing open, and another 2 terminal also showing open. Final 2 terminals it is displaying a resistance, that is 11.7 ohm. So that means all the phases are not showing equal resistances, so there is some problem in the motor and we have to take it for rewinding. After disconnecting the motor from the machine, we have to remove the gear pulley from the shaft by opening the locking pin with the help of a Allen key. After removal of locking pin, we have to use a puller to extract the gear pulley. First, the screw rod of the puller should be positioned at the center of gear pulley, and the legs of the puller to be tightened at the edge of the pulley by rotation of the handle. Then gradually the screw rod shall be rotated in clockwise direction for tightening. This will gradually extract the pulley outward and it will come out of the shaft.
ଏବେ ତୁ ସୁଟ୍ କରି ଜାଣିଛୁ ନା ନାଇଁ କହିଲୁ ରୋଟର ଯଦି ଲ୍ୟାଣ୍ଡସ୍କେପ୍
Now we have to dismantle the cooling fan. The cooling fan is mounted at the back end of the shaft. Hence, we need to remove the back end cover by removing all these bolts with the help of a wrench. This is the back end cover. This is the cooling fan. We have to remove this, but there is a circlip there for locking. We have to remove the circlip with a plier. Then for removal of the cooling fan, we have to heat it, and here we are using a halogen light for heating. Other modes also can be used like furnace or oven, but this is a small one, that's why we are using halogen light. You can use a screwdriver for removal of the cooling fan. Just to reconfirm, let us make the continuity test of the motor. We need to remove the terminal box by opening the screws one by one. We have to set the multimeter in continuity mode, and you can see first two terminals is showing continuity. Second two are showing open, and last two also showing open. Hence, it is confirmed the motor is damaged. Let us test the insulation of the motor by Megger. When we are shorting the two terminals of Megger, we can see it is displaying 0 mega ohm. When we are touching between two terminals of motor, then it is showing 2 mega ohm. Again, when we are changing to other two terminals, it is also showing 2 mega ohm. But when we are touching between final two terminal, it is displaying 0 mega ohm, which is far more less than 100 mega ohm for a healthy motor. Hence, this is not a sign that the motor is damaged. Now we have to remove the housing from the motor. For this, we need to lose all the bolts on the housing. Here we are using a mechanical rust cleaner to clean the rust. This is the back end housing. We are loosening the bolts both by wrench and hand. This is the front end housing. Here we are loosening with the help of Allen key. After removal of all the bolts from both sides of housing, we have to apply force on front end by striking it on floor and the rotor side will come outside. You can see here we are cutting it with a cutter and again demarcating with the help of a screwdriver. As the wires are thick, we have to cut by taking a small piece one by one. One coil is completely now has been cut. Similarly, other coils we have to cut them. We are doing this cutting of stator winding in one side of stator now. We have to identify the bending points of coil and cut at that point only. After total cutting of coils, we have to segregate each and every terminals. You can see here we are using a screwdriver to separate one with other, so that while removal it can come out easily. The insulation between phases also are getting removed. From the other side of the stator winding, we have to identify the pitch of the coil. You can see here one coil has been demarcated. The starting of coil and the ending of coil, gap between the slots is called the pitch. So this is one. 2, 3, 4, 5 and 6. So coil pitch is 6. We can check it once again. 1, 2, 3, 4, 5, 6. This is the starting. 2, 3, 4, 5, and this is the ending. Now to remove the stator winding, we have to fix it in a vice. You can see here the motor has been fixed at both the hand of the vice, and it is tightened so that it will not slip out. Now we are applying kerosene with a cotton over the windings so that you can burn it easily. As heating the winding will make the removal of winding easy, that's why it is being burnt with kerosene. Now we are applying fire to winding. After heating it, we have to use two tire lever or rod and hold one end of one coil and extract it outward. As it is already hot, it will come out with lesser force. You can see here the rod, and with the help of plier also we are folding it and extracting the coils one by one. Now we have to clean the insulation whatever left out in the slot with the help of rod. After removal of all the insulations, we have to put the motor on natural air cooling for few times. After cooling of the stator, we have to wash it with kerosene. We are now dropping kerosene and using brush to remove the particles inside, burning particles. We have to wash it thoroughly, each slot, surroundings also. Both sides of the stator we are cleaning. Also outside of the stator we are removing the burning areas. Between the ducts of the stator core, we are also applying brush so that it can be cleaned. We are using sandpaper also remove the dust particles. It will make the surface of the stator slot smooth so that new winding can be placed easily. Now we are applying pneumatic air to make it dry from both the end of the stator. Also whatever left out particles will be there, it will be thrown away to the force of the pneumatic air. After this, the stator needs to be made dry That's why we have to put it under oven or halogen light. Now we have to count the number of coils and the number of turns.
2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This one for counting.
So there are 12 coils in 24 slot and it is similar winding. Now we have to count the number of turns in a particular coil.
One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 70.
So there are approximately 79 turns, or you can say 80 turns.
75, 76, 77, 78, 79.
Now we have to measure the diameter of the super enamel copper wire used in the coil. For this we need to remove all the insulation covering over the super enamel copper wire. Here we are using a sandpaper to remove the insulations. We know that for measurement of diameter we use screw gauge or vernier caliper. Without removal of insulation, exact diameter cannot be known. That's why it is mandatory. Now all the insulation has been removed from the wire. This is the screw gauge or vernier caliper.
2 meter.
We have to fix the wire in between the two ends of the caliper, and it has got two scale for display of reading. You can see that the reading is
0.8.
0.8 mm. So for 0.8 mm diameter, the standard wire gauge table we need to follow.
So 0.8 mm.
So as per the standard wire gauge, for 0.822 mm it is 21 SWG.
Standard wire gauge 21. 0.82. Standard wire gauge 21.
So we have to use 21 gauge wire.
Yep.
After drying of the motor, we have to grind the inside of each slot with the help of sandpaper wrapping around a rod. We need to make thorough grinding. Of each slot. We can use sandpaper also to grind the surface of the slot. That is the top portion of teeth. This will make the slot core smooth and winding can be placed easily. After this, we have to use pneumatic air to remove the collected over the slot during grinding operation. After polishing of the stator slot, we have to cut the mylar paper and place it inside the stator slot as an insulation. Mylar paper is a class F insulation which can withstand temperature up to 180 degrees centigrade maximum and average 115 degrees centigrade. This is a oily type of paper so that coils can be placed easily, and also it can provide insulation between the core, slot and the winding. Here we have to cut the mylar paper as per the width and the length of the slot. We are using a ruler and a knife to cut the mylar paper. This is the width measurement. It has been measured so that it can be placed properly inside the slot, and the slot shall be covered. Now we are cutting it as per the length of the slot. This is for one slot, and accordingly we need to prepare for 24 slot. Now the mylar paper is getting placed inside the slot. You can see this. We have to fold at the end of the mylar paper both the sides. Then it has to be bent at the middle and inserted inside the stator slot. In this way, we have to put all the mylar paper insulation inside all 24 slots of the stator. Proper care should be taken while putting this insulation in the slot, because there are chances of winding can be touched with the core, and it can result to body of the winding and motor will not perform. You see that due care is being taken so that total slot is getting insulated with the help of mylar paper. You can see here we are making coil measurement 1 to 6, slot 1 to slot 6. This is the length of the, this is the width of the coil. Coil width from slot 1 to slot 6. Now we are measuring the length of the coil. We are using mylar paper just to measure. Now we know both the width and the length of the coil to be prepared. These are the standard measurements. Now we need to place this measurement on a plyboard and put nail as per the measurement at 4 corners. This is the width measurement. Now the length measurement is being done and nail is being used to mark. After putting all the 4 nails as per the measurement, we need to coil prepare as per the measurement. As per the standard term what we have previously found out, and as per the SWG used, so we have to make 80 turn with 21 SWG wire. This nail has been put just to mark the starting point. Now this is the turn.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41,
You can see this, the coil is being made and number of turns being counted. We have put the 21 SWG wire here and the wire is being coiled around the nail.
59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80.
Now it is complete. One coil is complete with 80 turns and 20 NSWD wire. We have to cut the coil and mark the starting and ending. Accordingly, we have to prepare this type of 12 numbers of coil. We are putting this to fix as a groove in all the 4 sides. Now the coil can be removed from the nail. The starting has been made, starting and ending had been made coiled, so that finally it can be used for connecting. The nulls are getting removed, and this is the coil. Before placement of coil in the slot, we have to make few calculations regarding the coil positioning and connection, so that desired numbers of pole formation can be made to get desired speed of the motor. This is 3-phase motor. Number of slots are 24. Numbers of pole can be calculated with the formula 120 F by P. So frequency is 50 Hz and RPM as per the nameplate is 1405. So 120 into 50 divided by 1405 equals 4.26, that is approximately 4. Hence we need to make 4 pole, and as this is 4-stage induction motor, speed will be less than 1500 RPM due to sleep. The layer of winding, as we have already discussed, is single. Numbers of coil will be total number of slot divided by 2 for single layer winding, but for double layer it will be equal to number of slot. So it is 24 by 2 is 12. Number of coil group to be used are number of phases into number of pole. So as we are having 4 pole, so it will be 4 into 3, 12 number of coil groups. So number of coil per coil group, each, as there are 12 coil and there are 12 coil group also, so it will be 1 coil per coil group. But in case of other motor also, there may be 2-3 coils per coil group. Accordingly, type of winding will differ. Pole pitch will be number of slot divided by number of pole. So 24 slot to 4 is 6. Hence coil pitch should be 1 to 6, and it is full pitch coil and concentrated winding. But in other motor, if distributed winding used, then 2-3 slots side by side can be used, but here only 1 slot is required for one side of coil. Connection is ordinary series connection, that is finish of one coil to the finish of second coil, and starting of second coil to starting of third coil should be connected, so that north and south pole formation can be made by series connection. Similarly, for other motor, there may be parallel connection or both combination of parallel and series connection. Type of winding we are using here will be basket structure to get a smooth and fixed rigid structure. Now we'll see how the coil will be placed. the number of slots per pole will be 6, and the electrical degree per pole is 180 degree. So electrical degree per slot will be 180 degree divided by 6 is 30 degree. Phase A, we have to start it, the placement of coil. Phase A starting A1, let us take slot 1 as reference. Phase B starting 120 degree electrical after phase A, so that will be 4 slot after phase A, that is slot number 5. Similarly, phase C starting C1 will be 120 degree electrical after phase B, which will be again 4 slot after phase B, and it is slot 9. Next, the phase A second coil starting will be 180 degree electrical after phase A first coil starting, so which will be 6 slot after phase A first coil starting, so it will be slot 7. Similarly, for phase B, the second coil will be at slot 11, and for phase C, it will be at slot 15. If you calculate the placement of coil in different slots in this way, we will finally get a table like this. You see here, there are 12 number of coil groups: G1, G2, G3, G4, G5, G6, G7, G8, G9, G10, G11 and G12. And for phase A, it will be G1, G4, G7 and G10. G1 coil will be from 1 to 6, G4 from 7 to 12, G7 from 13 to 18, G10 from 19 to 24. Similarly, phase B, G3 5 to 10, G6 11 to 16, G9 17 to 22, G12 23 to 4. And for phase C, G5 coil will be slot 9 to slot 10, G8 from slot 11 to slot 16, G11 from 17 to 22, and G2 from 23 to 4. Taking the inputs from the winding calculation, now we can place the coil in slot and we can prepare a winding diagram. Coil A group 1 from 1 to 6 slot, and it is phase A. Then second group is phase C. Similarly, third group phase B. This sequence ACB is getting maintained now. G4, G5, G6 are ACB. Then G7, G8, G9 are again ACB. Then G10 phase A. Then G11 phase C from 21 slot to 2 slot. Similarly, B phase G12 from 23 slot to 4 slot.
After completion of the placement of nailer paper in the slot and as per the winding diagram, now we have to place the coil in all the slots. This is the phase A coil. Will start from slot 1 as reference. We are using 2 nailer paper sheets and sliding the each wire with the help of a wooden knife to the slot. The nailer paper sheet are using as a guidance here. Each wire are getting inserted inside the slot 1 for phase A. This is the group 1 coil. The wooden knife is used and all the 80 number of turn has been inserted for the slot 1. Now we are putting the closing cover over the slot 1 winding. Then after 6 slot, that is slot 6, we have to insert the ending of phase A group 1 coil in a similar manner. As per the winding diagram already we have discussed, after group 1, group 2 coil is phase C coil and it will start at slot number 3. So there will be one slot gap between first coil and second coil. Now group 1 coil ending is getting inserted and it is completely inserted. Now we will provide again the closing cover of mylar sheet upon the winding at slot number 6. These closing cover are prepared similar as per previous mylar cover given at the slot bottom. Length and width has been taken care of. So group 1 coil is totally placed now. We have to fix it in proper way by using a mallet so that shape will be achieved. Now as discussed, we will insert the group 2 coil, that is the phase C coil, at slot number 3 phase C coil. One slot after the phase A coil. This type of placement of coil will lead into a formation of basket structure which are intertwined between each other and will get a good stable winding. After inserting the group 2 starting at slot number 3, we have to insert the ending at slot number 8 as per the winding diagram. H pitch is 126. So it will be from slot 3 to slot 8.
1, 2, 3, 4, 5, 6.
So coil pitch 1 to 6 is getting maintained.
এটা জাস্ট স্টার্ট হবো আর ইয়ে হবো সেତେବେଳେ করবো ହେଲା पॉज कर देते हैं थोड़ा ଆଜ୍ଞା ଖୋଲିକି ପକେଇ ଦେଇଛି ବଜା ଯୋଉଠି ମିଳିବ ବାଟରେ ବଜା ଦେ
After inserting two coils, we have to again make the shape proper with the help of a mallet. You see the coils are, as I told, are getting interlinked and finally a basket structure will be obtained. That's why we need to properly shape the coil with the help of a mallet. In a similar manner, coil number 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 will be placed, and the gap between starting of one coil to other coil will be one slot only. You can observe the placement of coil one by one.
फरक आसो स्टॉप करिबनि टच कर मोडा केमति कॉलटा मैंड कर सेटा देखि मोटर में I think was the count करने 1 say the note 1 2 3 4 5 6 तो बोल फोन और बिल्कुल नहीं तो रेडी फोन और गोटे गैप जोटा रही गोटे फोन एक समय बनाऊँ ना ये मन रही ହେଲା बस अच्छा ऊपर आसमान तारा दौना थी क्यों रोबान
The starting and ending terminal of each coil should be brought out properly, making a coiling arrangement so that finally it can be made connected with other coils. You see here, just telephone spiraling type has been done to starting and ending of each coil, and we are applying mallet so that proper shape of basket can be achieved. Both sides of the stator winding. During positioning of coils in the slot one by one, we can notice that while positioning of group 11 and group 12 coil, we need to leave the group 1 and group 2 coil starting side, position at slot 1 and slot 3. So now we are removing the insulation, mylar paper insulation over slot 1, and gradually the coil side at slot 1 is getting removed. Now we have lifted the slot 1 completely. Then we will go for slot 3. After inserting of group 11 and group 2 coil, we have to insert group 1 and group 3 coil side at slot 1 3 again. This is being done to get basket structure of the winding. Now slot 3 is getting lifted. The slot 3 is completely lifted now. We have lifted the coil side at slot 1 and 3. We will hold these two sides by tightening it with cotton tape along the yoke of the motor. Now the coil group 11 will be inserted at slot number 21 to slot number 2. This is the slot number 21. The starting side of coil number 11 is now getting inserted.
The wires are getting inserted one by one. Now the ending side of the group 11 coil will be inserted at slot number 2. You can observe the motor winding. One basket structure is gradually getting formed, where the coil formation is ACB, 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 and this is continuing. The group 11 coil is inserted completely now. Then the group 12 coil will be inserted at slot number 23 to slot number 4. We are putting closing mylar paper over the slot number 2 of group 11 coil. This is the group 12 coil. It will be inserted. Starting will be at slot 23. The pattern what we have discussed in winding diagram are exactly getting replicated while rewinding. Always due care shall be taken while inserting the winding so that two wires are not crossed. It will create problem while inserting other wire and space constant will come out. The closing cover of slot number 23 is getting inserted. Then the closing side, ending side of slot number 4 coil group 12 is getting inserted. You can observe that inserting winding we are taking proper care so that proper shapes is obtained, and also wires, all the wires are
inserted inside the slot. Now closing cover of slot number 4 has been put. Then you are releasing the cotton cap, and again the coil side of group 1 and group 2 will be positioned at slot 1 and slot 3, which will complete the basket structure. The name basket structure is because it is just like a basket where overlapping type of structure is obtained to get better stability. This is slot 1 is getting inserted. The super enameled covering on the copper wire is insulation. This helps in insulating turn to turn. Slot 1 is completely inserted now. We are putting the closing cover. In big motors, bamboo sticks or plastic sticks are also put over the nylon paper closing so that winding will not come out. As this is small motor, it is not required.